So here we are with the chapter 8 on kinematics, and we've got a little bit of sort of background information here at the start. You can use two-dimensional vectors. In fact, three-dimensional vectors can be used to describe how things are moving. But in this section, we work only with two-dimensional vectors. And we're told here if a particle starts from the point with position vector r0, so that's its starting position, and has a constant velocity v, then its displacement from its initial position at t is vt. So vt is how far it's moved. Okay, and its position vector r is now given by r0 plus vt. In other words, its position relative to the origin, r, is equal to its starting position, r0, plus how far it's moved, which is vt. And then they say in the rest of this exercise, unless otherwise informed, you should assume that I and j are unit vectors, due east and north respectively. In an exam, you cannot assume that, and that would have to be clearly stated as part of the question. Okay, so here we go. Example 1. A particle starts from a point with position vector 3i plus 7j. So I would think of r0 as equal to 3, 7, writing it as a column vector, and moves with constant velocity v, which is equal to 2, say 2, write 3, not a good start, 2, 1, minus 1 in the j direction. Check the units, meters for position, meters per second for the velocity. Find the position vector of the particle 4 seconds later. So we know r is equal to the starting position plus how far it has moved. Okay, so r0 is the starting position. So that's the starting position. And vt here is how far it's moved. How far moved. Is that bit there, that's how far it's moved. Okay, and if you add those two together, you get the position relative to the origin. Position relative to the origin, which is not necessarily its starting position. So we've got that, and we've got how far it's moved applied to vt, and the starting position is r0. So as usual, we've stated an equation, so we can now substitute in. So r is equal to r0, which is 3, 7, plus v, which is 2 minus 1, times the t, and in this case, the t we're told is 4 seconds. So we're going to get 4 seconds in there. So r is equal to 3 plus 2 times 4 is 8, which is 11, and 7 plus negative 1 times 4 is 4. So I'm going to convert my answer back to I and j notation, so it's 11i plus 4j meters. And I convert it back to the ij notation because that's the form that the question came in. So convert back to the form of the question. Convert back to the form of question. In this case, I and j. Okay, part B. Find the time at which the particle is due east of the origin. So, due east of the origin. Yeah, due east of the origin. Well, what's that telling us? Due east of the origin. Due east of origin. Therefore, what? Well, for it to be due to the origin, the northerly component must be the same. Yeah, north component must be 0, i.e. J component equals 0. So the J component must equal 0. So if we go back here, we've got R is equal to R0 plus VT. So again, we state our equation. And we've got R is equal to R0. It starts at 3, 7. And V is 2 minus 1 times T. And we want to know the time. So we've got to find the time at which the J component is 0. So J component 0, J component, that's what we're thinking about. Consider J component, so 0 must equal 7 minus 1 lot of T. So it's plus minus 1 lot of T. So 7. So T equals 7 seconds. Okay, I hope that's clear. Yeah. But the key is this bit of thinking. The J component is 0, so I've taken out the J component of here and made it equal to 0. And then T comes out to be 7 seconds. Okay, that's the end of example 1. I'll put example 2 on a new clip.